we will be looking at the assignments I suggested. The first one is a conversion of acetylene and hydrogen, and we are gonna start out by assuming that everything is converted. But some of the things you might be aware of in terms of the wordings, fractional excess. So in this case, we can see if we look at our equation, I have an excess of hydrogen, and we can actually calculate how much extra hydrogen I have. In this case, it would end up being 25%. So basically, how much hydrogen do I need? Well, for this reaction, I need 40 kilomoles if I have 20 kilomoles of acetylene. And then I have 25 excess. Fractional conversion, moles reacted over moles fed. But let's start out by looking at this one in Excel. So we basically just have one stream entering, one stream exiting, and we want to figure out what is going on. So if we look at our feed, I'm going to do it slightly differently this time, because if you look at the exercise, I'm being told how much I have of each, not the percentages. Normally we've been told percentages. This time I know that I have 20 kilomoles of that one, 50 kilomoles of that one, and hopefully no product. And if I then want to, I can calculate the total amount of moles by just summing everything up. Do that for the other stream as well. And that's my starting point. So the question now is, how much exits of the different components? That's basically my unknowns right now. The percentages, if I wanted to calculate those, I can easily do it. I can just take the amount of this component over the total amount, and if I want to, I can then drag it to the right. If I drag it down, we're going to have issues because Excel is going to try and divide by 0. So if you do this, you just need to put in some values somewhere. So I'm just going to guess at some values here. Now, when we start to look at reaction-based mass balances, there are several ways you can approach it. The way I suggest you approach it is using atomic balances. That's often what we see in biotech, that we use atomic balances to keep track of these things. So I want to somehow calculate how many moles of carbon atoms, hydrogen atoms, and so on I have in my different streams. The easiest way for me to do that is I always take all of the components that I have here, and I want to copy them. And then when I paste, I'm going to select Paste Special and ask to transpose my data. So that's basically going to take this row, turn it 90 degrees and put them here. And then I just start to fill out all of the atoms I have, in this case only carbon and hydrogen. And for each of my species, I look at the formula and I say this one contains 2 carbons, 2 hydrogens, 0 carbons, 2 hydrogens, 2 carbons, 6 hydrogens. So that's a way for me to keep track of this. And then in this case, it's a small enough system that this won't get too cumbersome. So I'm just gonna over here calculate how much carbon, how much hydrogen I have in my different streams. And I'm gonna first do it the cumbersome way, where I have to do a lot of stuff, and then I'm gonna show you the shortcut. So generally what I would do is I would say, okay, how much carbon is in my feed stream? Well, that must be how many moles of this component I have multiplied with how many carbons are for every mole of this one, plus the amount of this component times how many carbons that one has, plus the next component times how many carbons that one has. Now you might notice here that of course I could just ignore the last 2, because one of them has 0 carbons and the other one I don't have anything in my feed stream. But this is the systematical way I would have to do it. And then I have to do it again over for the hydrogen and say, okay, I want to take my first component, multiply it by how many hydrogens it has, my second component multiplied by how many hydrogens, and so on. And First of all, doing this by hand is really boring. We don't want to do that. Second of all, it's so easy to make a mistake as you go along. So we would much rather write one general equation and then use it all over the place. So instead of doing this, even though it works, you can actually check and say, okay, if I have 20 kilomoles of this component, I would have twice the amount of carbon. Works out fine. The way you would go about doing this automatically or more easily is you want to use the sum product. I want to take two, strings of numbers and multiply them together. So Excel has a function that's called sum product. So I want to take the two arrays. I have the array with the amounts of each of my components. I happen to know I want a $sign in front of the letters for that one. And then I want the array for my carbons. Now, because it's shifted, it's transposed, I have to transpose it again. Excel can do that for me, so I just type in transpose, and then I select my other array. Again, I happen to know I want $signs in front of the numbers, finish off my parentheses, and I get the same value, but instead of having to type it in over and over and over, I can now just fill it to the right, fill it down, and I'm done. I have now calculated how many carbons and hydrogens I have in each of the streams. And this is why I put in the $signs where I did. When I fill it down, I want these or this part of it. So I want it to move from here. When I go to my next stream, my product stream, I want all of these to go down one. So that's why I put a $sign in front of the, letters and not the numbers, because I want the numbers to change. I want to go from using the number 2 row to number 3 row. When I go to the right, what I don't want to have happening, let's do it with this one. When I take one step to the right, I don't want this selection to move with me one step to the right, because then I would be missing one of my components. I want it to stay there. I don't want the letters to change. So I put a $sign in front of the letters, not the numbers. The other one, it's the opposite. When I go one to the right, I want this selection to move from being here to moving over to using the hydrogens. I go from calculating carbons to hydrogens. But when I move down, so when I go down to this one, I don't want this red selection to step down with me, because then I would be using wrong values. I want it to stay there, so $signs in front of the numbers. The numbers cannot change for the red, the letters may not change for the blue selection. Now, when I only have two streams, doing the balances is super easy, because I can just say this is the amount of carbon entering minus this is the amount of carbon exiting. And I can do that for the hydrogen as well, in minus out, and I have my two equations here. So this would be, we can call it unit 1. Right now I have 3 unknowns, but only 2 equations. Degree of freedom is 1. Something is not specified. I need some more information. Now, if we start out by just assuming that all of our limiting reactant will be consumed, that means all of our acetylene will be consumed. Well, if I then go to my Excel sheet, I can change it and say, okay, if everything is consumed, that must mean nothing is left. So I can change this cell to 0 and say this is no longer an unknown. I know it has to be 0. Now I have 2 equations, 2 unknowns. All I have to do is set it up in Solver. So I open up Solver, ask that my first equation is equal to 0, add a constraint that the other equation has to be equal to 0, and finally I select my 2 variables. There we go. Hopefully when I ask Excel to solve it, it comes up with a solution. There we go. And Both of those trend towards 0. Everything looks fine. This is such a simple setup that we can already predict. If you look at the equation we have 20 kilomoles entering. We assume all of this is converted and they react 1 to 1. So I know that I should have 20 kilomoles exiting. And we can see Excel gets very close, 19.9999. Might work if we solve it again. Yep, then we get exactly 20. Still have a slight deviation from optimal conditions here, but that's something we can live with.